All right, now we're going to find the sum of a finite geometric series. So what is a finite geometric series? Finite means there's an end to it, right? So there's a certain amount of terms in this sequence, which we're going to call a series when it's finite. So a sequence goes on forever. A series has a certain amount of terms in it. Sum means we're going to add it all up, right? So a geometric series is a sum of the terms of a geometric sequence. So this is notation that represents a finite geometric series. So the sum is equal to the first term plus the first term times the common ratio plus the first term times the common ratio squared. And you're going to keep increasing the exponent on that common ratio until you get to the end. If you take that sequence and you multiply it by the common ratio, you're going to create all these terms, right? So you have the first term times the common ratio, and then the first term times the common ratio squared, right? So if you subtract that first sequence of numbers by the second sequence of numbers, everything cancels out except the first term of the first list and the last term of the second list. So what you can say is that the sum of all of those numbers is equal to the first term of the first sequence minus, since we're subtracting, the last term of the second sequence. So then the sum of those numbers minus the sum of the multiplied by r numbers, you can factor out the sum of the first numbers. And you end up with 1 minus r. If you divide both sides by 1 minus r, you end up with that formula. Okay, so that's where this formula that we're going to use comes from. So the sum of a sequence of numbers is equal to the first term multiplied by 1 minus the common ratio raised to the exponent of how many terms are in that series divided by 1 minus the common ratio. So this is notation for a series. What is the sum? So we're going to use the formula we just found in part A. That sigma notation means sum. Okay. These are the generic spots in the formula. So n, the number of terms in the sequence, is the number up top. So in this example, it's 7. In this case, the first term is a sub 1. And then the common ratio is 2/3, right? Because that's the value, that's the r there. So when you substitute those numbers in, you get 3 for the first term. The common ratio is 2/3. And the number of terms in the series, is 7. And those are the only 3 things you need. You need the first term, you need the ratio, and you need to know how many terms are in the sequence, in the series. When you evaluate all that, you end up with that fraction, 2059 divided by 243. When you go to check it, you can actually find the numbers in the sequence if you wanted to and add them all up, and you're going to get that value, right? So this formula is a shortcut for just recursively finding each term in the sequence and adding it up. All right, so we're going to try it over here. So pause it, give it a try, and come back and check. In part A, we're taking the series notation there. The 5 is the n, the 1/2 is the a sub 1, the 3 is the r. So we're just substituting those values into that formula, and you end up with 60.5, or if you want to leave it as a fraction, 121/2. In part B, you're given a series of numbers, and you have to figure out those 3 numbers. You have to figure out n, r, and a sub 1. Well, a sub 1 is the first term. That's the easiest one to find, right? So a sub 1 is -2. common ratio, since we're dividing by 3, that common ratio is going to be 1/3. All right, so we found out that. And the question is, how many terms are there in that sequence? Well, if we're dividing by 3, that 243 is 3 to the 5th. So if it's 3 to the 5th, the exponent would have been 5 on that 3, on that 1/3 that we're multiplying. So if the exponent was 5, then the n value would have been 6. So that indicates to me that there's 6 terms in the sequence. So this is the notation that represents that with those numbers in those spots. So again, 6 for n, -2 for a sub 1, and 1/3 for r. And then when you apply the formula and simplify, you get -728 over 243. All right, let's take a look at example 5.